Like, what do they teach in physics these days? Because we had a PhD, dude, and you're the Jamaican guy, right, brother?
Yeah, yeah, just me, bro.
Yeah. You're the same guy. You changed your name, right?
Oh,
Anyways, that's not important. You said you have a physics degree, right?
yeah, yes, that's correct. That's correct.
Okay, let me ask you a question. Since you're a physics degree, if I take my phone now and hold it up shoulder high, standing up, and I let go, does my phone fall and hit the ground, or does the ground rise up and hit my phone?
Well, fall is not a nebulous word, so you can't say fall. What you do say is your phone goes to the ground. That's what you say in the scientific community.
So the phone goes to the ground, not the ground rises up and goes to the phone.
Correct.
That's a 100% certainty, right?
Yes,
When I
absolutely.
let go of the phone drops and hits the ground. Yes?
Yes, it goes to the ground. Absolutely.
Okay. Because we had some guys saying in the past that no, it's actually the ground that goes up and meets the phone. So I just wanted to, pick your brain since you have a
No.
degree. What kind of degree do you have, if you don't mind me asking? A PhD,
Well,
a master's?
I've heard that discussion that yeah, it's like the ground that's moving up towards. Yeah, I've heard that discussion a lot. And so when you get onto quantum physics and all these kind of things, this is where these things are discussed. Also, Einstein's relativity and special relativity kind of alludes to this kind of unusual relationship between mass, right? So yeah, it can be represented in a way where the ground is moving to the phone, but in reality. Space time is being warped, right, between the ground and the phone. So the ground has a heavier mass, so the phone is actually going towards it.
So you think that the floor is warped, or the space time around the floor is warped like a fishbowl, causing the phone to fall in when I let go. That kind of
Yeah,
visuality.
absolutely. Yes, it's a three-dimensional what you call it, you know, inflection of the area around the ground. So the phone is going to be going into the displacement. Yeah, it's going to be going into that displacement. The phone doesn't have enough density or mass to change it, although it does have some that's interacting with the gravitational field of the earth, but the earth's gravitational field is just too strong, so the phone is negligible.
So now I'm kind of confused. So now you're saying there is a possibility due to quantum physics that the floor could be moving up? Is that what you're saying now? Because before you sounded steadfast, convinced that no, it's the phone falling to the floor.
Yeah, no, the phone is going to the floor. It's just that when you look at the equations that comes out of quantum mechanics, it would make it seem as if the ground is moving to the phone, right?
But
Yeah,
not reality, though. Not
but not
reality.
but
Some
not in
some
reality.
cockamamie idea involving maths, but in reality, we would say that's complete nonsense. Would you agree with that statement?
Absolutely. There's quite a few equations there that will show that the phone is moving towards the ground, and then if you kind of do some inversions there and some transpositions and stuff like that, it makes it seem that the ground is moving up. So yeah, it's very odd stuff, and all these things are still being studied. But the phone is definitely the one that's caught in the Earth's gravitational influence.
Why are y'all saying quantum mechanics? That's not quantum mechanics. There's nothing to do with quantum mechanics.
Well, quantum field. He's saying it, not me. He's saying it.
I know why. Why are you saying that? It's just relativity. It's just motion relative to other things. Why are you saying quantum anyway?
Well, if you look at general relativity, there are some places where there are weaknesses, right? Like when it comes to when you're talking about singularities, infinite gravity, Einstein's general relativity kind of starts to break down. So it brings us back to the quantum area now to talk about it. One of the mission of these colliders is to find out if there is a fundamental particle that's responsible for gravity. So yeah, so all these things are still being studied, and there's a lot of developments out there.
To measure how much the Earth would be moving back towards an object falling, you'd have to be looking at Planck numbers, right? They're extremely, extremely unimaginably small. That's why I'm not supporting it. I'm just saying that's the model.
Oh, exactly. Oh, that's very good. Yeah, yeah. That's you're looking at some of that, some of those very small, minute um, numbers, and that's in the Planck theory. Absolutely.
So back to the falling thing, right? You have to add a caveat. When I say when I drop the phone falls to the ground. You've answered, but every time you say it, you add a caveat to it. Can you not just say when I pick up the phone while I'm standing up and I hold it at arm's length, the phone drops to the floor. The floor does not move up like relativity says. Can you
Yeah,
not just say that?
yeah. I just don't like the word drop. And I don't
Why
like
not?
the word fall. Those words are not um, nebulous words. There's something going on there. You know. So we would like to say objects move towards each other. There's an inverse um, relationship between their distance and the size of the amount of matter they have in them. There's definitely a relationship there. So that's why we would say the phone is moving towards the ground, like everything else around on Earth.
What if you dropped a phone that weighed as much as the moon? Right, you had the mass of the moon and that small object. You dropped it. Or you could scale that equation down of how much the Earth does nudge toward it, down to the actual weight of a phone, and you would see the Planck like it trails off into some crazy, stupid small number. So I guess you could just say straight up it falls to the ground. But they're obsessed with exceptions. I guess science is obsessed with exceptions because of data.
Well, yeah. I mean, that's part of the scientific method. Is falsification process is big. I mean, scientists love to do that. They love to falsify stuff. And when they can't falsify something, they're like, oh my gosh, what's going on? But yeah, that's just in reality. So like if you're leaning, right? If you're leaning, so you're standing up straight, you're going directly, you're perpendicular to the center of the planet. So if you lean over, so what has happened? That perpendicular line is still there. It's just that you've shifted your body in a position where you can no longer maintain that perpendicularity with the center of the planet. So there's a fixed relative vertical point directly towards the center of the planet. It's fixed. It doesn't change. I don't know if that makes sense. It's like the only
You're
perfect
getting
thing.
full aggro with that.
Are
Right.
you?
The only perfect tool in our society, in our world, like I was talking to another gentleman, is our plumb bobs. Plumb bobs are the only perfect tools. They point straight down. It's the only perfect straight you can get
Okay,
towards.
before we go to plumb bobs, are you walking back your thing that the phone? It's not the phone falling; it's the ground coming up to meet the phone. Are you changing your statement to the phone falling?
No, the phone is moving towards the ground. It's not. It's not. It's not. I don't like the word fall.
But the ground is not moving towards the phone.
No. It's well, in a very minute way. I mean, the phone itself has gravitational influence. It is influencing the ground, but in a way that's like unimaginable. The gentleman a while said that you go to the plank of the planks on it. So yeah, I mean, the phone
So
is
it is moving. So it is moving. The floor is moving up, but just very little bit.
Yeah, like orders of magnitude smaller than like a human hair or like even probably a cell.
much smaller than that.
Yeah, like unimaginably small. Like what the hell small?
Like what? For-
But this is a new kind of cosmology now, because according to Einstein, the floor is moving up at 9.8 meters per second square, right?
No,
According to
no.
yeah.
Does it?
You
Does it
you
really
have
say
to
that?
identify.
Well,
Okay, if I
well
may,
then,
if I may, I don't know. It's getting very complicated. I don't know why we're talking about all this minutia and all this other stuff. It's if you were the accelerometer in the phone, you're the accelerometer, SE accelerometer, and I've got you in my hand, and I drop you. Oh, you don't feel any forces, and to you, the ground is coming at you at 9.8 meters per second, right? But if you were the plank on the floor looking at the phone, you're going to see the phone coming at you. If you're the individual holding the phone and dropping the phone, you just say the phone's falling to the floor. That's all. That's it. There's no more to it than that.
So you're coming in with a reference frame sidekick.
That is what motion is about. You have to identify your reference frame to know what you're trying to describe.
Nice. Elbow comes in. I mean, elbow. I was going to say left lane comes in with an elbow of reference frames, but what is actually happening though? Forget about
Depends
the
on where you
reference
view it
frame.
from.
What is actually
Depends
happening?
on your observation point.
So if I'm looking at it from a different observation, does that change the fact that I'm holding the phone, I'm standing up, and I let go of the phone, and the phone falls to the floor? If I look at it from another reference frame, does that change the actual fact, the actual motion?
No, I could be standing next to you, watching you drop the phone. To me, the phone's falling to the floor.
Yeah, but if you look at it from another reference point, does that ever change that fact, that actual fact that happened?
I mean, am I in a car going by watching you drop the phone, or am I in inertial frame in outer space watching this happen?
Yeah, let's say you pick
You got
any
to be
other.
specific about what reference frame you must identify an observer's reference frame to describe the motion that observer sees.
Okay, let me rephrase the question then to make it crystal clear. Is there any reference frame when I, in reality, stand up now in my living room, pick up my phone, hold it arm's length, and let it go? Is there any other reference frame that you can think of that can change that actual thing that happened?
No, the thing can happen. I'm not sure what you're asking.
You are sure what I'm asking. So there's no reference frame that I can look at that motion of that phone falling and change that thing that happened. Correct? In plain English.
Change of what? When you're saying change, you have to be specific. You have to say the change of velocity, the change of position. If you're talking about velocity, yes,
Any
would have
of those
changed.
things.
Yes, it would have changed. Definitely. If your reference frame would be movable, yeah, it would be. You would get a different result than a
I didn't say
immovable
the reference frame is movable. Keep up with the conversation. No one says you're moving the reference frame. You're
We said
just
any.
changing the location of which you observe the action taking place.
Yeah, if you change the reference frame, for example, if that phone is 2 meters above the ground, yeah, from your reference frame, it would be 2 meters. That has been kind of a travel all the way to the ground. If you choose a reference frame, let's say in half away, and if you just put your reference frame over there, you would get a different, y or a different, distance. Yeah, of course, the velocity would have changed a little bit. Yeah, it would have changed. If you change your reference frame, the kinematics would have changed. All the kinematic variables would have changed. Almost.
How? What you just said makes absolutely no physical nonsense, no logic whatsoever. If a motion takes place at a certain location, you can view at it from your grandmother's house across the street, from the gopher's point of view, from an eagle's point of view flying by, from a plane, from anywhere. Nothing changes the physical motion because you observed it from a different location, my friend. I don't know
When you talk about physical motion, you have to be specific. If you're talking about the velocity of it, the acceleration, the position, these are the things that we are considering here. I don't know what you're talking. When you're saying that the thing doesn't have any meaning in physics, you have to be specific to what factor you're talking about that you're considering.
It's not my fault you can't keep up with the conversation, bro. If you can't keep up with what I said, then maybe just stay out of the combo. I was very specific, very clear.
No, you're not specific. You're not specific.
Then what can I tell you? Then you're out of the loop, brother. Talk about something else. Very specific. I'm standing somewhere. I'll repeat it one last time. I'm standing in my living room. I hold my arm shoulder length straight out. I have my phone there. I let go of the phone. The phone falls to the floor. That is very precise using the English language of a situation that happened. Do you understand that? Let's start with that.
Yeah, I understand what you're trying to say. I could go on.
Is that a clear? So that's clear, right? Okay, now you tell me by which viewing angle you can look at that, what I just explained, and that will change the mechanics of what just happened. Please go ahead and enlighten us.
Well, in the first place, you have to tell us that where did you put your reference frame? Like what the thing that you sort of explain right now that you're holding your phone and you're just dropping it. So in this scenario, in the first place, you have to tell us where is your reference frame? From what point you're just calculating everything? Is it from the ground? Is it at your toes? Or is that your head? For example, if I put the reference frame on your head, I would get a minus the distance because it's going downward, and downward in physics means minus. So if I put the Cartesian coordinate system on your head, I will get a minus y, or minus vertical movement. Now, if I put the reference frame on your toes, it would be vice versa. I would get a positive vertical position, or positive movement. So it depends on where you want to put your reference frame, my brother. Literally, it's like that. I don't know how you have to explain it, but it
Isn't he
depends on where you
saying
put
the
it.
reference frame by saying he's holding out with his arm like straight out, like it's from his eyes, from or our point of view?
It's from his eye. It could be from anywhere else. It doesn't matter. It doesn't really matter. You can put it anywhere. It's arbitrary. It's completely arbitrary.
I just what?
Exactly. He thinks he's actually saying something now. But keep in mind, people are listening, and this is being recorded, right? So you're trying to make the argument that a physical motion that has happened will change because of the viewing position. That's the argument you're trying to put forth, my brother.
Of
And I mean,
course, of course.
it just sounds ridiculous, with all due respect.
Well, wait.
No,
Let's say let me help him answer maybe, because I know what the point of reference is based on what the story problem you provided, right? It's the viewer, right, from the where the head is, right, where the eyes are set in the in the human brain when you're dropping it, right? So that viewpoint would be from the viewer perspective, and we can all put ourselves in the position of holding the phone with our arm out and dropping it, and say that's the reference frame. There could be some, you could assume that reference frame might be like someone else watching you do it, not real, but I mean, I think you're being pretty clear. It's just,
Yeah, you can be looking at it from upside down, from across the street from the neighbor, like on the carpet upside down. You can be on your couch with your head upside down. You can be in any reference frame in the universe. I think that's pretty clear, right?
No, except the
Nothing
phone's
will
except for
change.
the phone's reference frame. The phone's reference frame will not describe the motion the way that you describe it.
You can describe it any which way you want. That's not that's the thing. The thing is, will it change what happens? And the answer to that, left lane, is no. You can be inside the phone. It doesn't matter. The phone is
Well, it
falling
does
and
matter.
hitting the ground.
It does matter if you are
Nope.
the accelerometer in the phone. See, the whole issue is y'all talk about the ground moving up towards something. The only place that's described that way is from the reference frame of the falling object. That's all. That's all there is to that.
no,
Yeah,
bro.
the only problem is we're not talking about describing, right? You can describe me as a woman, I'm still a man. You can describe the phone doing something else, it still will never change the fact that it left my hand and it's going to the floor. No matter what you say, left lane, I'm sorry, brother.
I don't even understand why you're saying that. I'm not arguing with that.
So what are you arguing with? A description? We're not talking about
I
describing
don't know. It's
something. We're
vague.
talking
It's
left lane,
because
left
it's
lane. I'm in the middle of talking, bro. We're talking about the actual physical action that's happening, not describing it.
you drop a phone falls to the floor. Everybody knows that. Y'all's argument
end of story.
comes in. Your argument comes in when we're talking about relativity and reference frames, and something in free fall has no forces acting on it, and the ground is coming towards it rather than it going down. Right? That's where the problem is in the argument right there.
No, there's no problem. We all know what happens in reality. The problem is this dude called Einstein tried to tell us and you, and you're trying to fall for that now. We're trying to somehow explain it away that it's actually the floor moving up. And I'm just trying to show that that is ridiculous. So you can't even let me finish the sentence. That's
but that's not it. You don't misrepresent what I said, and I'll be good.
I'm not saying what you said. I'm saying what the model says. And the model says Newton said the apple falls to meet the floor, but Einstein told him, no, 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 that's what they teach our children. It's the floor that goes up to meet the apple. Now, you don't have to go with that model, but that's what the model says. So if you're going to defend it, I'm going to make it clear that it's just ridiculous.
No, it's only described that from the apple's reference frame, though.
Yeah, exactly. You're talking about the relative motions in physics, and you're trying to dismiss all these facts. This is crazy. I am a flat earther, and I really get fucking mad when I hear these things. You cannot rule out relativity, and relativity has nothing to do with fucking Einstein, my brother. Einstein came up with special relativity and general relativity, but relativity is something different. It is something that we're talking about right now with you about it. That the velocity, acceleration, and positions depends on what is your reference frame. That's it, my brother.
Negative. You're absolutely wrong.
Yeah,
you
can say that.
I just showed it to you in real world. The phone goes down to meet the floor. You've been convinced that the floor goes up to meet the phone. That's on you, my friend. Don't try to play high and mighty with me that I got it wrong.
No.
You're the one that has it wrong, buddy.
No. I understand your view. You're saying that just because it hit the floor, it doesn't matter from which reference frame you're looking at it. We do understand that the phone is hitting the floor. But the problem is that with what velocity and with what accelerations? When you want to calculate those variables, you need to set your fucking reference frame, my brother. That's all I'm trying to tell you here. That's it.
Negative, brother, negative. Nothing you say or do is going to change the fact that it's the phone falling and hitting the floor, my brother. Do you
It won't
understand, my
hit the
brother?
floor, but the velocity, and you can make a relative velocity. If you would have been on another motion vehicle, and if you look at this whole thing, it would be things will be different. The velocity, you get some relative motions here, and your calculations are going to be a little bit different. But it doesn't change the fact that it's hitting the
Negative. Nothing you do or say will ever change the fact that it's the phone hitting the floor. Negative.
We know
No
that it's hitting the
calculations.
floor,
No
bro.
reference
We're
frame.
saying with what velocity, in what position, and what
I
is the
don't care
acceleration
what
of that thing.
doesn't matter. You could be
Oh my
going
God.
100 miles an hour. You could be going 1,000,000 miles an hour. Nothing will change the fact that the phone hits the ground, my brother.
We know that. We don't want to arguing with this shit that you're saying. We know that it will hit the floor in any reference frame. The point is that we're telling you that these variables would have changed if you change your reference frame. Now, if you want to stick with that, it doesn't matter. It doesn't matter. It only hit the floor. Oh yeah, okay, it hit the floors. No matter where you put the reference frame, it always hit the floor. Nobody's arguing with this with you.
But so what are you arguing then? What are you trying to say then?
I'm saying that, my brother, that a lot of things in physics depends on where you put your reference frame. It depends on.
So what does that have to do with the phone falling? Why do you feel you have to come in after I make a logical statement and tell me, brother, it has to do with the reference frames? Why do you feel the need to come in and add that? Why, brother?
You said that if I change the reference frame, it doesn't change the fact that the phone is hitting the ground.
Correct.
And I said that, yeah, okay, but the way that
why do you have to say but?
Because the but is very important. The but is that it tells you that how it hits the floor is the question here. The how it hits the floor, with what velocity, with what acceleration. You know, these are the things that
I just told you. It doesn't matter. Listen again. Listen to my answer.
It doesn't matter.
Listen,
it doesn't matter.
Bro, stop interrupting. Listen to my answer to your question. It doesn't matter the velocity that it falls. Do you understand that? The amount of speed that it falls to the floor doesn't change the fact that it falls to the floor.
Of course, it doesn't change the fact. Yeah, it's hitting the floor.
Okay, so that's end of conversation, right? The phone falls and hits the floor, right, brother?
So, okay, what are you trying to point out here? Okay,
see, you can't say it, bro. You just can't stop there, right? You just can't. You got to say more. Go ahead, bro. The floor is yours.
No, this is trivial. Okay, I didn't know that you're trying to bring up this dumb point here, but I thought that you're talking about relative motions. But you're just saying that it always hit the floor no matter where I look. It will hit the floor no matter what you do. It will hit the floor. Yeah. So what?
Okay, so end of convo, right? And that's where the conversation ends. The phone hits the floor, right, brother? And then we can move on, right? Right, brother? We can go have a beer, yes? The phone falls from my hand and hits the floor, right, brother?
Nobody disargue with you that it doesn't hit the floor. Nobody disargue that.
You can't say it. You gotta say more, right? Go ahead, say some more.
If I may, it seems to me like the reason the conversation can't stop there is that that's not where the conversation started. The conversation started, if I heard correctly, in comparing the phone hits the floor or the floor hits the phone. Did I misunderstand that?
The thing here is, yes, in reality, when I'm standing up and I hold my hand shoulder length and I let go of the phone hits the floor, correct? That is the answer. And not the floor. The phone falls down and hits the floor. It's not the floor that moves up and hits the phone, correct? Is that a correct statement?
That's not correct according to the phone, but that would be correct according to you.
Yeah, you know what, man? You just stay in your fantasy land. I already said it. I'm not going to go through it. If anybody else wants to keep up, I think I proved my point. I'm out. I'm out of this, bro. Stay in your fantasy. The floor moves up to hit the phone.
We understand exactly what you're trying to say. But if you put the reference frame on a phone, as this dude said right now, it's the floor that is hitting the phone, not the phone. So it's a relative. It depends on where you put your reference frame. And I do understand that why you fail to understand this is because most of you guys, most of the flat earthers here, everywhere, they're uneducated people. That's it. That's all it is.
Do not start ad homing. Do not do that. You're not going to get away with it. Just don't do
that. That's pressure, dude. That's that pressure guy. That's not even. That's a new. He said he was a flat earth. This is pressure. That's that Jamaican dude.
In fairness,
why is he trying to pass like he's freaking flat earth?
That's not Robert. Robert was talking earlier, but that's Kazra. He's not joking around. He is a flat earther.
Yeah, I don't think so.
I am a flat earther, and I do believe that Earth is not flat and stationary. when the phone hits the ground, if you put your reference frame on the phone, it will appear that the ground is hitting the floor. It's hitting the,
Are you also
the
Jamaican?
phone. No, bro, I'm not Jamaican. Do I sound Jamaican?
You sound just like Pressure.
No, the guy. I don't know Pressure is. No, I'm not. I'm Casper. I'm not. I probably you guys know me. I believe in this two-pole flat Earth model.
Are you
Yeah.
the
So
concave
anyway,
guy? Are you the concave guy?
no, don't
Okay.
bring those concave.
All right. My bad. My bad.
Yeah. No, bro, no.
Look, it's a free world, bro. You can argue that the Earth is moving up, bro, but you're gonna get some pushback, especially from me.
I heard. I just did dive into all things on this concave model. I think it's called Christopher. What's the name of that guy? I don't know. He was in jail for 2 years. Anyway, the guy that actually, because it's based on hollow Earth, and this concave Earth, it's way different than hollow Earth. That hollow Earth that we knew before. It's something different, and they believe in very 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 weird stuff. Like probably you guys know, there's an upward curvature instead of a downward curvature. There's an upward curvature, and the sun, everything is in the middle of this hollow Earth, and we're living inside this shell, and and the rest of it. So I heard them, man. I think that these people, I mean, these groups are more like control opposition. If you were to think about, like, even the Gleason map was as I always argue, even before the final experiment, I told the flat earthers that the AE map is not right, it's not correct, it's from NASA. Even Alexander Gleason never spoke about the sun movement around this map. He just did a survey. That's it. But we flat earthers made it like a model for ourselves, and it's wrong. It's basically this Gleason shit. It's wrong. So yeah, I believe in this two-pole flat Earth model. I think this is the model that all of you guys will one day come to it. But it'll take time for a lot of people to understand it. Anyway, but here's my
Talking
point.
magnetic poles? Are you talking magnetic poles?
Yeah, they are magnetic as well as geographical. They're geographical and magnetic both at the same time. Like the
Well,
globe
then,
model. So the two
let's-
pole.
Yeah, how do you
let me
test
ask
that
you
model?
this then. Why does it appear that we're on a monopolar place? And it
Well,
appears
no, it
that
doesn't
I
appear
know there's
that.
no such thing as a monopolar magnet. But why does it appear
Mhm.
that way?
So why do you think it appears like that? If you go into Australia, if you just go across the equator, if you go into the other part of the world, you can see the Southern Star. Now, I want you to understand that Southern Star and Polaris,
Don't go to
they
stars,
do.
bro. We're talking magnetism now. Don't go into space.
He might need to for you to understand, SE. You don't naturally understand everything, so hear him out.
Oh, here we go.
Oh, yeah.
Here we go.
Well, exactly. If I'm talking about them, if I want to talk about magnetic poles, first I need to show you that where are those centers in the sky. For example, you know that Polaris is one center, and you're saying that the North Pole is exactly underneath it, right? So when you believe that Polaris is exactly above your magnetic North Pole, then I'm going to tell you that on South you have the same construction. There's a point called Southern Point. It's in the Octave constellation. We don't have exact a star in the middle, but it's a point that you can see that everything is going around it. Now, that southern point or that southern star, whatever you want to call it, if you come vertically down to the ground from that point, that will be your that will be your south magnetic pole. So the difference between the two-pole flat Earth model and the monopole one that we believed before is that in this model, we have two poles and we have two centers on the sky. One would be Polaris and the other one would be the southern star. And now why we have to believe in this model is because we need the sun to be below the equator for 6 months of a year. In the Gleason map, you couldn't justify, those problems that probably you guys know about it, like the 24-hour sun that we couldn't explain in Australia and a lot of other things. But this model can explain
You
everything.
can explain it
Also,
with this.
well, let's do one thing. I just said to Jill, let's set up a day or something. We need a schedule, and I need to bring some materials for you guys to understand how this thing works. But if you guys search for Michael Wilmore on flatearthsociety.org, the guy, he was the first guy who proposed this two-pole flat Earth model, and that goes back to 2013. And but he didn't explain how the sun and moon and the rest of the things move on it. But we will gradually explain everything on this model. I'm just making all the videos with my colleagues, and I'm going to put it out in English as well. Don't worry. But if you guys want to do your own research on this model, you can start off with just search for Michael Wilmore, the vice president of the flatearthsociety.org. And later we're going to talk about this.
Flat Earth Society.
Oh yeah, the Flat Earth Society is where we're gonna go for sure. Yeah. Mhm.
So you're from the
Listen,
Flat Earth
brother,
Society?
we're veering off course here now. Like this guy's just
No, I'm not from
plugging
that
us along.
society. No, I know some of. I'm not. They work in Portland, in England, in the United States. Their main office is in Portland. No, I know one of them.
Hold on, bro. Hold
and-
on. Before you go on and on, please, hold on. Now, John is here. I'd like to ask him a question before we go on to what you're saying. John, can you talk for a second? I want to ask you about the falling thing. If you got a second.
The falling thing. Yeah. Well, go ahead. Mm-hmm.
Okay, thank you. Because we talked about it before, and I think you said it, but somebody, Jeremy, thinks maybe that I wasn't clear enough, or you misspoke, or whatever. Let me just ask you clearly: If I'm standing in my living room and I have my hand out shoulder length and I have a phone on it, remember that combo we had, and I let go and I drop and I let go, does the phone fall down to hit the earth, or does the earth go up to hit the floor, to hit the phone?
Well, you can think of it either way. It's just a reference frame problem. What we know for sure is that the phone and the Earth collide. If you look at it from the frame of the Earth, you'll say the phone fell to the Earth. If you look at it from the frame of the phone, you'll say the Earth came up and hit the phone. That's just a reference
So
frame.
hold on, John. You're walking back what you told me. That for sure, we know for sure that the phone falls and hits the floor. Now you're changing your mind.
No, I never said that. We know for
Oh
sure
my God,
that
I'm
the
gonna have to
phone
go
and the
find the
Earth.
tape.
I never said that. We know for sure that the phone and the Earth get closer together and collide. That we know for sure, and we know for sure that when people standing on the Earth watch that, what they see is the phone moving toward the Earth. But that's just because of the reference frame that they're in.
Okay, let me follow up then. So let me
Trying to
follow
say
up. So, hold on, bro. Don't come in left lane. So let me be perfectly clear in what you're saying. You're saying that, and I'm trying to steel man you here. Correct me if I'm wrong. You're saying the action of me actually picking up the phone, standing up, and dropping the phone, that action changes depending on how you look at it. You, John, PhD, that's your claim.
Well, the thing you just said was pretty different from the thing you were asking me about, and I'm not sure, frankly, what it was in that thing that you just said that you're asking me to pass judgment on.
I'll repeat it again. If you weren't sure, I'll repeat it again to be crystal clear. The action of me dropping the phone, can that change? Can that action, not the description of the action, can that action change from any way you look at it, from any reference frame? Sir John,
in other words,
PhD.
okay, so would looked at from any reference frame, would somebody say that it wasn't you picking up the phone and lifting it to your shoulder height?
No,
Okay,
not
well, that's what I
say.
thought I heard you say.
Let me repeat it again. Because this is the problem. Maybe people don't listen. The action of me picking up the phone, holding it to my shoulder's length, and dropping it, that actual physical thing that happens, irregardless, now let's say you look at it from a different reference frame, does that action change? Not the description, not the way somebody sees it, but the actual physical action that takes place. Can that change depending on a reference frame that you look at it from?
When you're saying action, he
That's
doesn't
not to you,
understand.
bro. That's not to you. That's not time for you to come in. That's
Oh,
for
sorry.
Gave you
I
the
thought I was.
exact same answer. He gave you the
That's not
exact
for
same
you.
answer.
I thought I was. I was muted. So I think you're asking me. The action you're talking about is you picking up the phone, lifting it to shoulder height, and then letting it go. Right?
Correct. And
Yeah. No.
it
Everybody would
falling and
agree with
hitting the
that.
floor.
Everybody
All right.
agrees with that. Everybody agrees that you bent over, picked up the phone, lifted it to your shoulder height, and let it go. Nobody could possibly disagree with that.
Regardless of any reference frame, you're sure 100% that I picked up the floor, and I picked up the phone and it dropped and hit the floor.
Yep.
100% sure.
You picked up the phone, you lifted shoulder height, and you let it go, and then subsequently it hit the floor. That's right.
And nothing can change that. You cannot say that the floor lifted
Jesus,
up.
what do you? It feels like you think you have a gotcha or something. I'm not sure what it is.
That's what I
He's looking
felt
for
from
an
it.
absolute reference frame. That's
No,
what
I
he's
just
looking for.
want
An
to be
absolute
clear
reference
on
frame.
that.
When he says what's happening in reality, that's what he's asking.
You have to go to physics school, bro. You have to go past physics course to understand it. Please.
Yeah. Keep your ad homs to yourself, bro. If you don't have anything to say of substance,
No,
stay on
because
mute.
we're repeating the same thing. John is a glober. He's a PhD. I am a master's. I am a flat earther. We're saying everyone is saying the same thing to you, but you just keep back going to if I draw, it doesn't change the action. Bro, when you talk about action, what
Keep your emotions to yourself, bro. We're having a conversation. Keep your emotions to yourself.
No,
So, John,
you're always you have to talk.
you
You're the
agree,
you're
bro?
you
Just
always
keep
talk
your
here.
emotions to yourself,
That's how it
bro.
comes. You're the older one who's talking here. Always, your monologue.
There's SE trying to neuter someone again.
I'm not trying to neuter him. He's ad homing me, right? He's telling me I don't understand. He
You're
has
the
a
only person
master's.
that is
We
talking
know,
here more than
we know
everyone
these
else.
games, bro. We know these games. So it's not. If you think you're gonna intimidate me in some way, it's not gonna work, brother. So if you don't have anything to say of substance, like stay on mute, bro.
We're just stuck in this ridiculous conversation that you're talking here. We're just tired of this
No,
ridiculous
there's double
conversation.
standards in here. If anyone talks the way like SE talks, they get muted or timed out. It's just it's the double standards in here. So
No, it's not double. What did I say that I should have get muted? Tell me. Go ahead.
there's double standards in here.
You just have a personal thing against me, bro. That's all it is. So it's not gonna work. I'm telling you, it's not gonna work. What you're trying to do is not going to work. We're talking about a physical matter, a person having a phone and it being dropped. Now, I want that conversation, the statement to end there. But you guys, no, you want to keep going. You want to say, well, it depends on what reference frame you look at it. And now you're getting triggered because I'm keeping you on point.
That's the thing. You want the conversation to stop. They don't. And
I don't want the conversation to
you're the
stop.
one that wants it to stop. And they're not getting triggered. They just feel strongly about something that maybe they know more about than you. So you're playing the arrogant judge. You're playing the conversation curator. Maybe you're speaking to someone that knows more about something than you do. Stop trying to tell them how they should explain things, do things, think things, go about things. You don't know everything. Maybe you're wrong.
No, you're just triggered. No, I made
ladies and gentlemen, no. So what I said is no. SE is the one that knows.
Stop your emotion, bro. Stop your emotional tantrum and let me talk now. No. What I'm saying is, and what I'm showing is that I made a simple statement. You take a phone, you drop it, it hits the floor, period. Now, these guys are trying to come in and tell me no. On another, if you look at it from another reference point, it's going to change the action. And I'm just not letting that slide.
They're not
now.
telling
if
you.
If you want to call that me doing something against the grain, that's on you, brother.
They're not coming and telling you. They're countering your idea. It's not about you. It's about the truth. It's about the idea. You're putting yourself, your ego, in the middle of it. It revolves around your ego, and that's what.
No, you came and made it about me.
It is about you. It is about you. I said what I had to say, bud. I said what I. Hey, you can listen.
And you're free. You know what? You can
listen to Castro a little bit more. He knows a lot more than you. He's closer to the truth about the FE than you are. Okay, stop dismissing.
You can say, Buddy, this is an open forum. You can say anything you want. You're even free to cry about me. Go ahead.
If we're free to say it, then stop trying to steer the conversation.
I'm not trying to steer it, and what you're doing is just simply not going to work, bro.
You are. You're deluded. You are.
No, you got a personal thing. It's just not going to work. You have anything to say about
personal against
go ahead.
You're making it a personal thing, bud.
No, you are.
Let's carry the convo.
Let's carry it on. Sure. What do you got to say about the convo? What do you have to say about something falling and hitting the ground? Go ahead. Or you want to talk a little bit more about me or somebody else personally?
I think we covered it pretty good.
Well,
so what conclusion did we reach? Are we all concluded that when I pick up my phone and let go, it hits the ground? Did we all conclude that?
I just like the idea that we could somehow disagree on that. It's what's funny to me.
Me too.
No, that's not what we disagree on, but SE is loading a lot of assumptions into that. And I want to ask you a question directly, SE. Are you assuming in either of those cases, the phone hits the ground or the ground hits the phone, that the phone is stationary or the ground is stationary?
No, I just made a simple statement. I pick up the phone, I hold it arm's length, I let go, and it hits the floor. Period. End of story. Every human being on the planet understood what I just said.
So what is it you think people disagree on?
You tell me. You guys think that the floor might go up. There could be a reference frame view that you can look at it that could change it. You heard the conversation we've been having.
Well, this is SE's argument against describing motion. When we go to describing motion and we start talking about reference frame, this is SE's argument against that argument, not that conversation.
Yeah, but he fails to realize that he's actually describing something. He says a fact, but all those pretty words in a row, that's a description.
No, look, man, we can do this all day, right? And I'm free. I can do this all day. No problem. There's nothing that you guys can say here that's going to change the statement, what I said. I pick up the phone. I let it go. It falls to the floor. I'm going to say it 100 more times. Nothing you guys say will change that statement. Understand that.
With that, SE.
All right.
We agree with that.
I know everyone agrees with that. But when you drop the phone, when you let go of the phone, what's actually moving in reality?
The phone.
Is it the ground moving up, or is it the phone moving down, or is it a combination of both?
They've been double speaking on this for 2 hours now, Jeremy.
I told you.
No,
bro.
this is the question.
Dude, you thought
go ahead,
it
Jimmy.
up the other day. I know. I tried to tell you, Essie. You thought you had it sewed up, but bro, they can't tell you.
Everything is moving. Every single thing is moving.
Well, you know what, Jeremy? You're correct, because he did tell me, but now he walked it back. I'm gonna try to find that tape. It's unbelievable. But yeah, you are correct, Jeremy.
I know it, bro. I know it. Like they can't tell you what's actually moving unless we start talking about his Earth rotating, then they know exactly what's moving. Other than that, though, they can never tell you what's moving, what's actually moving.
Yeah, and somehow I'm wrong. Somehow I'm steering the conversation. Somehow I'm the bad guy for merely just saying when you lift up the phone hits the ground. It's beautiful.
You're not.
Should play
You're
the
not a
tape back
bad.
in.
You're not a bad guy, SE. You're just wrong. That's all on some
You see?
things, not on this.
Let's see. I've been listening. My wife's been listening. She's more like, oh my goodness, the stupid argument. Because here's the thing, I'm still trying to figure out. I'm still waiting for them to say a reasoning on why you would be required to have a master's or a PhD to understand why the floor and the phone are moving towards each other. I
Amen.
like that.
Exactly, brother. Exactly.
Why do you need a degree to understand that? Where in the degree or where in the education do you learn such a thing besides it being a hypothetical to explain certain other observations? Like things that
You
are being
will learn
spit out
about
right now,
relative motion.
things that are being purported right now by the globe side to explain certain things that they want to be true are literally in the realm of hypothetical and are not science fact. They're not observed science. They're things that can kind of be explained through an equation, but they are not something. They're just a hypothetical to try to explain or try to fix a hole in a theory. So why the numbers being held onto like solid facts when anything else that's given to try to do something like that is just done away with?
Hang on, but these are the fundamental things about physics. These are pretty simple concepts, but where the PhD and the master's comes in, it would probably I don't know that I could. I don't know. There's so much more to it than that, and you get into engineering and things like that, and all of these things come to light. This is why this is that way, and how you can apply that knowledge to manufacturing or design and even architecture. Yeah, there's a lot more to it than just understanding relative motion.
Right. So the other thing too. The other thing.
Fanciful words to make it sound like the ground and like we all understand because there's three things. It's either you're picking up the object, it holds a stable stillness, and the ground is moving up towards it, or the thing is the ground is still and the object is what's falling towards the ground, or they're both moving towards each other. Those are the three perspectives that are being spoken of. Now, the one that fits into all engineering, architecture, and everything else is when you drop something, it's what falls. Not that the ground is moving. That's not how everything is operated through engineering, architecture, and all the fields that you just said that would be applied in. None of it operates in that idea that the ground also is moving.
That's brother. The fact that you had to say that is just astonishing.
Yeah, but the thing is, I mean, where the degrees come in is a lot of math is involved, right? So and practice with a lot of these equations. So and so when people are hypothesizing that the ground is going up, it's all it's all in math. These are equations. These are equations. It's just a description, right? Doesn't necessarily mean that the ground is coming up, right? It could be, but it doesn't mean it is. As far as all the math that makes real good sense right now is that the phone is indeed going towards the ground, right? That's all. Those are the real things.
Can
it's not imagination, but imagination.
I wanted to say as I have in the past, it's not there's no argument here about what happens physically, right? Things collide and they potentially break when they collide. It's and I have no trouble. You can describe that in many different ways. It is just a reference frame thing. Choose the reference frame you want that makes the analysis of the problem simplest. And most often, that means a reference frame where the surface of the Earth is stationary and things fall toward it. That's just convenient. But you do have to, at some point, you have to at least have an explanation for the fact that things do have absolute accelerations. There are devices that will measure the acceleration. An object can carry it. You're carrying one right now. Your phone has an accelerometer in it, and it will tell you what your acceleration is, and it will tell you that you are accelerating upward at 9.8 meters per second squared. And if you drop that phone, it will tell you that it is not accelerating. So you have to have an explanation for that. That's all I'm suggesting.
That's just again imagination. That accelerometer is in the phone, at least, is programmed with the software that's all based on those mathematical equations, and so you end up jumping into the realm of imagination. You do.
No, that's just not true. That's just not true. The accelerometer in your phone is a mechanical device, and it simply measures the stress in that mechanical device. And when there's no stress in that mechanical device, it knows that it's not accelerating. That's it.
Yeah. Can I just say that in like in English, in like in regular speak? What this gentleman, a PhD, is trying to explain to us now is the following. The phone that we actually see falling, because of some gadget in it, he says that it's not falling. But the ground that we can tell is not moving, because that object is on it and it's showing something, he says the ground is moving. That's what he's trying to sell you here, ladies and
That's
gentlemen.
not what I said.
I pulled
And
this
it's
in
not
here.
what I'm trying to sell you. It's not what I
Tell me
said.
what I
because
said.
it's-
Correct me. Correct me,
It's not
Johnny.
what I said, because the one thing that I've tried to be clear about from the start is there's no such thing as absolute velocity. You cannot say the velocity of that object is whatever. You can't say that. There's no way to tell what the velocity of an object is
Who said
except
that? I never said that.
relative to something else.
You said what you said is because of a certain mechanism on a phone that it's showing that it's not falling. That's what you said.
No, you're mistaking. You're not understanding the difference between velocity and acceleration. Those are two different things.
Is the phone falling? Yes or no?
The phone is getting closer to the Earth, and from the frame of the Earth, it looks like the phone is the thing that's moving. They're getting closer together. They will collide. Nobody disagrees about that. Nobody.
I told
But
you.
hold
I told
on,
you, dude.
yes,
That's all they
there is
can
a
test.
disagree.
That's all
Hold
they
on,
can
Jeremy,
say.
please. This is crucial, bro. Please. So are you saying that we do know that the phone is actually falling to the ground?
No, we do
My
not.
God.
Because the assumed, or Essie, he's saying that the assumed reference point that commonly makes things simple is assuming that the ground is stationary and that the phone is falling. One thing to note in an experiment is when the two objects collide, or when an object collides with the ground, does the ground give any force? Like, does it have an accelerated force, like a kinetic energy through acceleration that then hits the object that's falling? Like there should be a way to show that the ground has a form of acceleration too, because either the ground is going to just absorb, like since it's stationary, it's going to get hit with the object. Energy is going to transfer from that object into the ground, and yes, can bounce back to that object. But if both objects are accelerating, the ground should also show some type of force coming, like some type of energy transfer that happens from an upward force or from
Yeah.
from an accelerated force.
It does that. It's the fact that it's now no longer moving and it has weight, right? The balance, the forces are balanced upward and downward. They're balanced out, and motion cease.
Whenever
No,
two
no, 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 no,
objects
no, 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 no,
collide,
no. If you're, if you like, let's say you shoot something at the ground, or you're creating a larger force, um, the the force coming from the ground moving up, you should be able to have a sensor on whatever it is that's going towards the ground to see that there was also a force coming up, and it wasn't just that the kinetic energy of the device going towards the ground got put into the ground. And then,
all
a reverberation of that energy went back to the device. There should be a separate force that also hits the object that's hitting the ground.
this is called Newton's third law. Every time one object exerts a force on another, that other object exerts an equal force back on the first object. It's that simple. Every single time.
Huh. I shouldn't be able to punch through walls, should I?
What?
I told you guys. They think you can. You'll get lucky. You get lucky at some point. All you gotta do is hit the wall 80 like quintillion times or something. And eventually your hand will go through it. But I told you, man. All these guys will say is that the ground and the object that you let go of or that's falling, all they can say is it gets closer together. They can't tell you what's actually moving. They don't know what's actually moving. Highest
But he
level
did-
PhD.
Everything is actually moving.
He did say it last
It's
time.
the highest level PhD. They don't know what's moving when you drop something.
We
I
went,
know,
we
it's
went through
crazy.
this for like an hour. Everything is moving. Everything. Every single thing in that scenario is moving.
Yeah, but in the situation of moving, as in the 9.8 meters per second squared, what's moving in that? We know you got us flying through space at 1,000,000 miles an hour, but between the ground and the object, which one's moving? Is it the ground moving up, or is it the object moving down? It doesn't matter if we're flying through space and you're on a globe and all kinds of other goofy shit's happening. It's irrelevant.
Well, how are you measuring it? Where are you putting the accelerometer?
We're asking you if you know what's moving. I know what's moving. Do you not know what's moving? You're acting like you don't know what's
Everything's
moving when you
moving.
drop something.
Right.
Everything is moving.
That's not even a relevant thing. Left lane, you're roboting. That's not even a relevant thing to say. We're talking about the object and the ground. Is the object going up and it's at the same time the ground is going down? Are they splitting? Is it 4.1 meters per second for one and 4.1 meters per second squared for the other one? Is one of them going at a constant speed and the other one's accelerating? Are they both accelerating? What's going on? We're trying to figure out just in this scenario, saying everything's moving If you just say everything's moving again, I'm probably just going to leave the chat because this doesn't even sound
no,
like
no,
fun.
that's fine. So now that you've specified the question, if that's the question, then it depends on the reference frame. I know you don't want that to be the answer, but unfortunately, that's simply what the answer
No,
is.
that's fine. So you don't know. You don't know. You're like, it depends. I don't know. And you don't know. It's fine.
Jeremy,
No, you do
anti-gravity.
know, but you just need to be more specific with the question.
There's someone in
Tell me what's
anti-gravity.
moving. If you know, tell me. Hold on. If you know, tell me what's moving. If you don't know, say it depends on what reference frame and how you want to look at it.
Sure. So if you are on the Earth, the phone is moving down. If you are the phone, the ground is moving up.
So you don't know
It's
what's
not an
actually
idle-
moving. So you don't know. Well, that can't be the scenario in both cases, obviously. So do you know in reality which
It
one's
is.
actually?
It's the same scenario.
Don't cut me off. Cut me off, please. Give me a reason to start removing people from this combo. So when it comes to something dropping, obviously that can't both be the situation. If I'm on the ground and looking at you and you're skydiving, we both can't say. I can't say that I'm actually moving up at 9.8 meters per second squared, and you're actually moving down at 9.8 meters per second squared, because then we would meet at faster than 9.8 meters per second squared. So obviously it can only be one or the other. So you don't know what's actually moving in reality. We got it.
That's not true. So if you're moving up at 9.8 meters per second squared, I'm moving down at 9.8 meters per second squared. To you, I'm stationary, and to me, you're stationary. So it can be both.
No, you would meet at faster than 9.8 meters. We time it out. You would meet at more than 9.8 meters per second squared. It can't be both. It can't be both. We would know because you would meet faster. You guys are just saying like this. So I'm saying, SC, they say anything. They're just making up. What do you call it when you make up shit on the spot? Is that a fallacy?
Now that you're just insulting me, can I interrupt you?
We're just making shit up. You can't have it. You can't have them both be going up because they would meet at faster than 9.8 meters per second squared. We can measure it. We can measure it. We can
They're
put a
not
measuring
both
tape.
moving in the same reference frame.
We can put a measuring tape
They're
in
both
between
moving
these
according
people.
to their own reference frames.
Their impacts would be neutralized as well. There would be
It wouldn't be
almost
neutralized. They would meet at faster than 9.8 meters per second squared. We can put a tape measure in between this and measure it, and it's 9.8 meters per second squared. So obviously, the guy can't be moving down and the ground's moving both up at 9.8 meters per second squared. It can only be one of them.
Wait. Okay. So in that scenario, who's holding the tape measure?
It doesn't matter who's holding it. You can have either one holding it, and it's only happening. Oh my God! Oh please. Last warning. Don't interrupt, please. It doesn't matter who's holding the tape measure. If it's the guy or the ground, it's both only happening at 9.8 meters per second squared. So it can't be both of them because we would know it because they would hit the ground faster than 9.8 meters per second squared.
9.8 meters per second squared is the speed at which they're getting closer together. Which one you choose as your reference frame determines which other one is moving.
Well, once again, can I just? I think the problem is there's still a confusion between accelerate. Okay, I got interrupted. I got interrupted.
You don't need it. Yeah, we don't need it. Go back to back. I want to respond to that. You guys are just going to spew globe shit over us all day with your nonsense reference frames. At least let us respond in between the bullshit. SC, did you want to go?
No, you go. Go ahead. Let him respond. At least, yeah. Let Jeremy respond.
Yeah, I'm saying, do you want to get in this, or because I don't even want to be in this, honestly.
No, I was doing this for an hour, bro. Please go at it. If you can, they're double speaking. That's all they're doing.
This has been going for an hour. We could just switch it up. That's fine. This goes nowhere anyways. They don't know what's going on. They're just double speaking shit. It's like
they're gonna accuse. No, don't do that because they're gonna accuse us of trying to change the subject. That's what they try to come in and like we're the host. The combo. Yeah,
we're the host. We can make this go any way we want. If you want to sit here and bicker with these guys, go ahead. If that's gonna happen, though, I'm just gonna.
Jeremy, there's actually a lot of people that want to engage with you on this topic, but you keep threatening to time people out. So people are.
He was interrupting me. I know he was interrupting.
They're actually afraid to engage with you. That's what's going on.
He was interrupting me.
Hey, Jeremy, you know what the perfect test?
Can I mod people for interrupting or no? I mean, what are you concerned trolling right now? What are you doing?
No, you let out a statement and no one responded to you, and then you thought about maybe changing the topic. I was letting you know that 30 seconds prior to no one responding to you, you were threatening to time people out. So just letting you know.
No, I only threatened I never threatened to time people out. I threatened to move people from the conversation because they were interrupting me consistently. One time, two times, it's getting to be a problem. It's getting heated. So don't worry about how the modding happens. If you guys want to carry on with this, go ahead. I'll be back.
No, he's one of the guys. Don't let him do that. He's one of the guys that came in to try to do. See, this is what they're trying to do now, right? Instead of engaging in the topic when I had them squared, they brought up modding like I'm trying to change. That's why I brought this up. And he's the exact same guy that came into, so guys, just stay on topic, man. We're not muting you. We're not silencing you. Like, grow up, man.
But you just made the claim that I'm one of the guys that come in here and try to do things. Listen,
you did it to me before, correct? Yeah.
Why are you speaking over me when I speak?
Well, that takes care of that. If you just can't understand that, you're not going to come in here and we're not going to allow you to do that. It's just not going to happen anymore. We're going to stay on topic and we're going to talk logically. That's it.
I can say something right quick about the topic. So look, this frustrates me. Y'all know I'm a glower, but this frustrates me when my side we do this. Like we overcomplicating the
It's
question.
crazy, right, bro? Yo,
We
what the
know.
fuck?
Hold on, real quick, Jeremy. We know. This the globe side I'm talking to. We know that there's no such thing as absolute motion. We understand that. Now, when the flat earthers come in, they ask us a question like, "Oh, you drop a ball, which one's moving?" We already know what reference frame they're talking about. We don't need to overcomplicate it and be like, "Well, from the sun and from no, the ball's moving now." Just keep it simple, so we don't stay on this topic for 4 hours.
Exactly, bro. Exactly. Don't play word games.
Yeah, and I
Well,
agree
no, the
with
problem
that.
is. All right, go
Okay,
ahead,
never
John.
mind.
Go ahead, John.
Yeah, I agree with that, Carlito. But the problem is that the flat earthers want to take it further. It is just a reference frame thing. They want to make it that we know for sure which one is moving. And you know that's a meaningless statement. I mean, I guess I would ask, how do you know for sure which one is moving? You can't, because there is no way to know what your velocity is. It's a meaningless question.
Well, I mean, you could definitely figure out which one's moving if you're on a ball and you drop things on all different sides of the ball at once. Like, you know what I'm saying? If you have a ball and we put a person every square meter and someone drops something and we can measure, oh, this moved at 9.8 meters per second vertically down. And we know all the angles and how fast everything fell and everyone's timing it and everyone's watching it from outside, inside, everywhere. You could absolutely know which one moved because there comes to a point to where the ball would have to expand.
The only test that would satisfy, like, true, in my mind, would only truly satisfy the Glovers when it comes to motion would be for an anti-gravity craft to sit still to where it wasn't being affected by the proclaimed motions of gravity, the 9.87 meters per minute squared. And if it sat still, the Earth would have to come up and meet it at some point if it was moving up.
But sorry.
Its measurement between the ground and its base would end up changing if the ground was moving. But like I said, it has to be an anti-gravity machine for them. I mean, I could figure a balloon that has a rope or something attached to it, and that balloon is able to maintain its elevation by floating, where it's not falling or rising, but just maintaining elevation in the atmosphere. And whatever's hanging from it, the distance between the ground and whatever's hanging from it should end up closing. The ground should end up meeting the bottom of the rope at some point. But
No.
in that experiment, they would say that the balloon still has the effects of gravity upon it, and so the balloon is maintaining that distance from the Earth because it's doing its thing. But an anti-gravity machine, with completely going against gravity and taking gravity out of the equation of it maintaining a set elevation, the Earth would end up having to meet up to its base if the Earth was moving. That's the only experiment I can see that would safely them.
Yeah, I mean, with the whole thing dropping thing, you know, it gets to a point to where if you know, see that you with this whole reference frame thing, you got to like limit yourself, and this is all you can know in the universe is you're the guy falling, and that's it. You can't talk to it. But see, we're humans though. We can communicate with people. We can get different point of views, measure things. So we can in fact figure out what's dropping, especially if you live on a ball. If you think you live on a ball, now it's easy because now you're talking about the ball having to expand or not. So, I mean, I don't even know why they do this. Do they know we live on a ball? And right after this, we're going to argue, and he's going to tell you about how they 100% know Earth is rotating. After they get done telling you we can't know what's actually moving. So, I mean, it's all fucking stupid. You know what I mean?
Can I get in and to respond to Yahweh? I thought that was, I mean, it's a good example, the hovering thing. And we do have an anti-gravity machine. It's called a rocket. And so I want you to imagine that you are in a rocket ship and you're firing the thrusters such that the accelerometer in your rocket ship says you're accelerating at 9.8 meters per second squared. In other words, here you are in this rocket ship. You feel just like you do on Earth because the floor is pushing up on you, right? The rocket, after all, the rocket is accelerating. I hope I've painted a clear picture of that. And now you look out the window of that rocket and you see that you're actually just hovering 3 feet above the ground.
Good example.
Wait, what? What were you trying to express with that one? You're trying to express that the thrust of the rocket is countering that feeling, and that's what makes you feel stationary. And so that's showing that.
So I think the best way to think about it is imagine that there is a thing called outer space and you're in a rocket ship. and you're firing the engines of that rocket ship so that the floor of the rocket ship pushes on you, right? Because the rocket ship is accelerating. It runs into you if you're floating in it at first. And then you can kind of stand up. If the rocket ship accelerates at 9.8 meters per second squared, then you can stand up on the floor of that rocket ship and feel just like you do on Earth. Let me just, I have more, but I just want to, is it clear what I'm saying?
Yes, I clearly see what you're trying to present. I just, while you're presenting it, all other examples, such as driving in a car, standing on a bus while it's driving,
Well, I don't, can we not go there? I
instances.
just want to be sure that you understand that before I
Oh,
finish the
I
argument.
understand your what you're trying to portray, but that's what I'm saying. In other life examples, it
No,
doesn't.
but please don't change the subject. Do you understand that you would feel just like you do on Earth if you were in that rocket, firing
You're
its
part of the rocket.
thrusters?
You're a part
Sorry,
of the rocket. You're attached to
you're
the
in the
rocket. You're
rocket.
part
Yeah,
of the rocket.
you're.
John,
It's
please,
a
you've
You're with the
interrupted
rocket.
three
I
times in a
understand what
row.
you're saying.
This guy,
it's a cartoon
you guys
rocket.
need
You're just
you guys need to calm it down a little bit, please.
standing up
Maybe.
on the floor.
Can you guys hear me?
Yeah, I can hear. Sorry.
All right, please, John, stop interrupting.
Well, I didn't think I was interrupting so much. I was just trying to get a yes or no. Do you understand the situation? I
I'm
think
not
I've
a
made it
child,
clear.
John. I'm a fellow
Okay.
adult. So yes or no conversations. You're not a cop. I'm not going to oblige in that. We
Okay.
can have
Fair enough.
intellectual dialogue. But yes or no ain't gonna work, bro.
Okay, fair enough. But so I think I've painted that picture, and now all I'm asking you to do is imagine that you are in that rocket. It is firing its its rockets. It's firing its engines, and the accelerometer on board the rocket does tell you that you are doing just what you expect that rocket to do, to accelerate at 9.8 meters per second squared. And now you look out the window and you notice that in fact you're just hovering 10 feet above the ground, 3 feet above
Yeah,
the ground, whatever. You're just hovering. And I just ask you to imagine how you explain all that.
I understand what you're portraying. By being one with the acceleration of the object, it appears stationary. You feel stationary. I get that. And that's what the whole perspective is on Earth. It's moving, you're with it, you're moving too, so it feels stationary. I get what you're showing. That's why I said when you use that same thing to everything else that we like, if you're in a car and you're driving, if you're on a bus and you're able to walk on the bus, though it's flying down the road at 70 miles an hour, you're on well, actually on a BART, you actually feel it. Because I'm from San Francisco. I take the BART, Muni transportation a lot in the Bay Area. But when you're on the BART, one of my favorite things to do while I was on like ride from one end of the city, I'd go to the I'd get on the BART at the very last train on the very last segment of the train. You could go in between the segments. You can walk through it as it's moving. And I would do that. I would get on at the very end, and I would walk through the train because it's almost like a full city block long. And I would walk through the train. But as you're walking, you can feel the motion that's being pushed against you. You can feel the acceleration. It's not like you're stationary, but again, you're going against it. So it's like if you're going against the Earth's velocity, you should feel it. If it was moving, you should feel it.
Well, there's a lot of you're confusing many places in there. Velocity and acceleration, they are very different things. And I
I
think that's
apologize.
part of the problem.
I apologize. I'm using velocity in the sense of just the force that occurs through acceleration.
Velocity is not a force that occurs through acceleration.
I understand that. You just showed me that I was using the word incorrectly. That's why I was just trying to clarify what I was using the word for, though I was using it incorrectly for that.
So you describing that the plane is going 500 miles an hour? It's not accelerating, but you can feel it.
You can feel it bumping, right? I mean, that's the problem is that you can feel
No,
bumps.
we're talking about feeling, and we're talking
Yeah,
about feeling the speed. I feel like
right. I
that's what he
know.
was saying,
No,
and
I
I want to know
understand what you're saying.
specifically: is that what you're saying?
On a
Yeah,
plane, I
I
have
think so.
not had that feeling where you get up at your seat, go to the bathroom or whatever, and you feel like if you're walking towards the back of the plane and you feel that motion as if the plane moving forward and you're counter. I've never felt that on a plane, but
Great, that's perfect.
on a light rail, on a metro, on the subway, I have felt that. So what's the difference? One's attached to the ground and one's not.
What's the topic?
Phones dropping, elbow. Phones dropping.
I don't know what instead of velocity, would the correct term be the pressure? of the acceleration? Like trying to figure that one out. You told me the
Well,
word. I
so
was even trying to figure out what
yeah,
right word would it be.
so acceleration, when we say 9.8 meters per second squared, the better way to say that is 9.8 meters per second per second. That means every second you're moving 9.8 meters per second faster in velocity than you were a second ago. That's what acceleration is. It's a rate of change of position. It's what we call a second derivative in calculus.
Okay, so what is the force that's exerted on an object during acceleration? Pressure?
So no, force. I mean, the thing that makes an object accelerate is a force. So when you are standing in that rocket ship, the force that is making you accelerate along with the rocket ship is the fact that the floor is pushing on your feet. And that's exactly what happens when you stand on the earth.
I understand that's what you're going for with the example. I understand that. What I'm trying to understand is what is the force exuded on the object that's accelerating?
Well, usually it's a force on your feet. I mean, when you're in a car and you go around a banked curve, then either it's some frictional force from the seat you're sitting on that manages to keep you from sliding across it, or if there's not enough friction, it's the fact that you run into the door and hope it doesn't bounce open and it pushes you in that direction. But
No,
something
so
causes it.
when you have, like, let's just say you're accelerating through an atmosphere, you are going to have a measurable pressure simply because there's an atmosphere you're moving through. So what is that called?
Well,
What is
okay,
that
so
called?
you're right that when you move through an atmosphere, the force is distributed over your body, and you can think of it as a force per unit area, but it amounts to the total of that is the force that makes you accelerate. It's force that makes you accelerate, not pressure. Pressure is the amount of force per unit area.
I am not talking about what is causing you to accelerate. I am talking about what is exuded upon you when you accelerate through a medium.
Well, when you move, you don't have to accelerate. When you move through a liquid or a gas, there is a dynamic pressure, it's often called, because of the fact that your motion through it can be looked at as it pushing on you, like a wind or a current, right? Is it the water pushing on you or is it you pushing on the water? Depends on your reference frame. A wind in one reference frame is just you moving through the air in another reference frame.
Man, it almost sounds like you have to have temporary cognitive dissonance to factual things in order to flip your reference frames.
No, it's easy for them, bro. They have duality. That's the way it works.
Yo, before we go on, SC, before we go on, can you guys just admit you don't know which one's actually moving in reality, the thing you drop or the ground?
It's not that easy to tell what's
Hold on,
moving,
Andy.
Jeremy.
Hold on,
Jeremy,
Andy.
no, let
Andy,
me ask
hold
you.
on. Hold
John's
on,
answered
Andy.
me a million
I'm trying to get a
times.
concession. I'm trying to get a concession.
I'm just trying to lay it out basically. Very, very
Can we
simply.
just let one of the guys that was fighting that just now just either concede or not concede? And I just get some kind of answer or recognition that I'm alive?
Oh, okay.
and
So
ask
I've
me a
given you the
question?
answer. I've given you the answer before, Jeremy. It's not that we don't know which one is moving. It's that the question makes no sense. There's no such thing as absolute velocity.
If something's moving at a constant, how do we know? How do we know, Jeremy?
What?
If something's moving at a constant rate, how do we know?
How do you know it's moving? Because like,
Yeah.
if let's say you had a tree, right? Let's say you had a tree and you had a car, you would know that we know how trees work, we know how cars work. You would know that I'm moving.
Reference
The
points.
guy in a car. Yeah, you would have a scenario. You'd be like, okay, in this area, what's moving? Is it the whole thing could be moving overall. Like, let's say that's happening on a cruise ship. There's a car and a tree planted in the ground on a cruise ship. But if you're just worried about like what's moving, did the car hit the tree or did the tree hit the car? In that scenario, you can 100% tell because we know how cars work. Like, you drive a car 30 miles an hour into a tree and be like, we know that the car hit the tree.
I was just trying to make the point that if something's moving at a constant rate, it's not straightforward to know that it's moving, is it? Right? Because we only
That's
measure
some
change.
radical thinking there.
No, we only measure change, Jesse. It's very basic, simple stuff.
Yeah, it's reference points. We measure speed by
Yeah, we only know something's moving at a constant rate by another reference. Right? That's the only way we do it. So there's no other way. Think about it. No equipment's going to measure it. So in order to know if something's accelerating, you're going to need an accelerometer, which is works on the principle of displacement. Right. So when you say it's a digital thing and it's built into no, it's you can use it with a basic half-filled bottle of water, which is a rudimentary form of the same thing. Obviously, there's different forms of accelerometers, but if it's working on the principles of displacement and water, there's a basic thing we can see. We can see how something accelerates because of the force that's exuding. It pushes it one way or the other. But if it's moving at a constant rate, then you've got no idea.
Yeah, Andy, that's why I drew a distinction between the one the phone uses, because the digital ones do go off an electrical current, a displacement through electricity. It's not necessarily a displacement through the movement of mass, like it's alluded to, because when it comes down to these more digital ones, it is more it's tricky. You read into it, it's a displacement of the piezoelectric property through what they're calling displacement, but the displacement itself is an electrical current. So it's like when to say that the phone's accelerometer is going to measure the Earth moving upwards or accelerating upwards. We have an electrical force coming forth from the Earth.
No.
So,
MEMS accelerometers are absolutely one mass in relation to another mass. It reads and displays and interprets electronically, but it is absolutely one mass moving in relation to another.
Accelerometers work by detecting the voltages that result from deflections in the elements that hold the known mass.
Yeah, what causes the deflection? One mass moving relative to the other mass.
Like I said, the detecting the voltages that result.
Yeah,
So
yeah, detecting the voltages. Exactly, but it's not purely electric, and it does have to do with physical motion between two objects. So you just got to be careful about how you say it.
In Andy's example of a water bottle and seeing that water displaced, that time of accelerometer is what is being conflated with the accelerometers and how they work now. Like that's what I'm pointing out.
Oh, okay. I apologize. It just sounded like you were just talking about this electrical gradient in the atmosphere and magic causing an accelerometer to give a reading. But that's what it sounded like.
No.
A piezoelectric crystal generates a voltage that tells you about the stresses. So if you support a piezoelectric crystal and you then accelerate it, that will be because there are forces acting on it, and those forces will cause a stress, and that stress produces a voltage, and you measure the voltage. But the voltage isn't there unless there's a stress, and there's no stress unless it's accelerating.
And that's where the argument would come into about the electric universe and showing that there's a constant electric field. So the electrical displacement of an element being read as acceleration only fits within, again, a certain reference point. If you have the reference point that the Earth is moving and all these other things that we're floating in space and we have all these, then that's what you're going to view. That's the perspective you're going to view what's occurring. But the same thing also can be explained from another perspective. So then it comes down to which perspective is correct.
Well, see, the thing is, that's the nice thing about piezoelectric crystals and about acceleration is it's not a matter of reference frame. There is such a thing as absolute acceleration. And the only way you can make something accelerate is by exerting a force on it. And forces make things deform. Piezoelectric crystals measure the amount of deformity by generating a voltage. You measure the voltage, that tells you the deformity, and that tells you the acceleration of the piezoelectric crystal, the absolute acceleration of the piezoelectric crystal.
Is electricity a force?
Yo, imagine there's a tree planted in the ground. Some guy's driving at it at 30 miles an hour, and it crashes into the tree. And you're standing there like, I don't know what was moving. We don't know. We'll never know. It's all relative. The tree could have been going at the car.
Okay, cool. Go all right then.
Brings hitting a parked car into a whole new perspective. Was it really parked? Wasn't it in motion?
When things
Can you
collide.
imagine this convo on CNN or Fox or anything? Yo, Mr. Professor, can you tell me if I drop my phone, what's falling? And the professor says, well, we're not sure. Can you imagine that on live TV?
Dude, the fact that the majority of people don't know these responses. If they did, they would treat them as foolishness. But because they don't, they believe that they have the acceptance of the masses when they don't.
Yeah, that's why a lot of people say, don't talk about the model. I say, what? Talk about it as much as you can and be as descriptive as you can about the nonsense, right? And just let people listen to it. They don't know what falls. They don't know if a phone is falling or if the ground is going up. Imagine that one statement on TV.
A tree, a baseball game. Imagine if you don't know if if the ball's moving towards the plate or the plate's moving towards the ball.
Yeah, Yeah. During a baseball game, right? Second inning, intermission, commercial, and now, ladies and gentlemen, we go to the physics report. Just to make sure, we're not sure. Does the pitcher, does he pitch the ball, or is the batter moving towards the ball? We'll get back to you. Second intermission. And now a word from our sponsor, Coca-Cola.
Yeah, seriously. We know what's moving in some scenarios. Like if you want to know what was moving, was it the tree moving at the car moving at the tree? Like we just know how cars work. We know how trees work. We know how cars work. Like we know which one was moving, which one was moving at the other one.
Not only this, but all these things were engineered under the understanding that the Earth is stationary.
Maybe. Anyways, it's not even fun to talk about anymore because they just play some word games and it just gets frustrating. I don't know. I mean, we've been over it. We should go back and clip the parts out where we've talked about it, and I don't know. But as far as knowing what's moving, I mean, you can at 100% know what's moving.
Well, if that's why I asked you the question. If it's moving at a constant, Jeremy,
did you hear my response?
If it's accelerating, then we absolutely know what's accelerating through the principles of displacement.
Did you hear my response to that? I answered you.
Jeremy, you're interrupting Andy laughing at himself. Please.
Jeremy's the only one allowed to interrupt.
I answered that though. Did you get my response?
I can't remember. It's ages ago.
It was 5 minutes ago, Andy.
Well, it's ages ago to me. What time it real? What's the what was it?
In the scenario, we have a tree and we have a car, and
right.
They collided. You know, it was a nice little impact collision. About 30. We can do forensics. It was about 30 miles an hour. The tree's just planted in the ground. You know, we want to know, was the car moving at the tree or was the tree moving at the car? We 100% know that the car was moving at the tree.
Right,
because that's how we can tell what's moving and what's not in some scenarios, because we know how physics works, right? We know how cars work. We made the freaking car. We know how trees work. This isn't Lord of the Rings.
Yeah, but there's a difference between measuring something that's like time over distance. But in order to measure something, if it's accelerating, if it's moving, then we have very sensitive equipment to figure that out. So we do know what's accelerating. And it'd be disingenuous to say otherwise.
Andy, when was the last time you witnessed two trees collide?
Well, I mean, technically, I've heard this weird thing about trees do actually move. They can sense weird things and move away from dangers and shit like that. But we aren't going down that road. If I just look at this cup here, I know that this cup is relatively stationary to me, right? That's the whole point of it. The whole point of this is about relative motion.
But sometimes
Jeremy, one sec. I gave the example of the car. If you go in like 40 miles an hour down in a car down the road, and you throw a ball out the window, you just drop the ball. What happens from your point of view? It appears to go backwards, but from someone outside, it actually carries on in the same direction. So it's just all about relative. This cup here that I've got this next to me on the table is relatively stationary to me. You seem to be overcomplicating things that don't need to be overcomplicated.
I just think you're taking that scenario too far, Andy. Like, it's one thing to apply that scenario in like a world view scenario like you did. That's fine. But when you start applying that to celestial bodies, right, and conceiving that Earth is doing all these things that we can't validate, that's where you kind of fall off the block there, dude.
I wouldn't even take it to Earth yet because we can't even. Some people can't even figure out if the car's moving or the tree's actually moving, and it's a silly question to even ask. But the thing is, Andy, in the car and the tree scenario, you know which one was moving, right?
Yeah, the car's moving.
Yeah, the car's at 100%, right? The tree's not moving; it's planted in the ground. We know how cars work. You just drove all over the country. We know the car was moving into the tree, right? That was the thing that was actually moving. Yeah, all right. Just checking.
This John seems to know what he's talking. I kind of like him. The problem is, I think.
Well, ask him if the tree. Ask him if you think that Andy, before you think he knows what he's talking about. Ask him if the tree or the car's moving in that scenario. Ask him which one's actually moving in reality.
He doesn't seem to answer things in a straightforward way. Is what I was just about to say. I wish he'd just. Sometimes I don't think you can oversimplify it enough, right? Like he goes into a bit of a complex thing when he doesn't have to.
Let's do this. Well, what about if you're going to do an illustration on the computer and you've got your point of view is on the tree and a car's coming at the tree. So how would you do that illustration? Of course, you would have the car coming at the tree. But if you're going to do that same illustration, a little computer generated thing, and you were camera on the car, how would you do that illustration?
You need a background. You need other objects.
You would have the tree, very simply, not to complicate it, you would have the tree coming at the car.
Yeah, but left lane, we're talking about in reality now. You're in a physical car in your body outside, and there's a tree in a car. What do you think, left lane? Which one's moving, the tree or the car?
Where's the camera?
You can have a camera everywhere.
Each camera will have a little bit different perspective, but the motion is all relative. It just depends on where you describe the motion from.
What SE is saying, or what left lane is saying, is correct in an illustration where you only have a tree and a car. Like this, and the camera, depending on which one, is going to make which one look like it's accelerating. Either the car is going to look like it's sitting still and the tree's accelerating toward it, or the perspective of the camera is going to show the car moving forward towards the tree. But what brings all this into reality is we have other background information. Like as you're accelerating in the car, you're passing by other things that would show the tree to not be moving at the same time. So in your example, yes, but your example doesn't hold to reality.
Oh yeah, it does. Because in the car, with the camera in the car, and you're describing these things going by, you're making all those other things move. Your camera's sitting still.
Again, like I could. My major was computer animation, game design. Like I can animate this entire thing for you, and without background information, such as houses, such as other plants, such as the road itself, it would look like one or the other is moving dependent on your camera's perspective. You are correct.
Exactly.
But
Yes. That's all of it right there in a nutshell.
What I'm pointing out though is, in reality, we don't only have the tree and the car. We have everything else as well. So when you add in the rest of the information, you're able to dictate what is actually moving.
You don't need anything more than the information about the tree and the car. That's the only information you need. How do cars work? How do trees work? Okay, there's a collision, 30 miles an hour. You don't need to know anything else.
I agree with you, Jeremy, but this is the issue where it's like we're having the discussion with other people who believe we're a floating ball in space and everything else. And so that being their a priori basis, they already have this other concept of motion and all that. So that's why in his idea of just a tree, just a car, there can be this whole other thing. It's because it's rooted in that whole orbiting body, ball in space. That's the whole core concept that people need to understand on why they keep going to where they're going in this conversation.
Now they're doing this because you can describe it from either scenario. You can say, oh well, it looks like this is moving, or it looks like I'm the one moving, or it looks like. But we're trying to get past the looks like part and say what's actually happening. And they can't go there. They can't go to like actually in reality.
Yeah, I agree. That's why they keep having to use examples, which drops out all the rest of the information of reality.
Yeah. Before we get too far away from it, y'all are giving a perfect example for me driving down the road, and the world's moving by at whatever speed I'm going, 70, whatever. It's the same way with the Earth and the stars. I know I'm driving down the road, and that's why all the things seem to be moving past me. And it wouldn't make sense to think that the world is moving past me. I'm the one moving, obviously. Same way with the universe and the Earth. It's just an astonishing idea to think that the entire fucking universe, everything in the universe, all the stars, all the planets, blah blah blah, is what's moving, and I'm sitting perfectly still. That's like me saying I'm sitting still and the world's moving past me in my truck. It's the same concept.
No, because anybody sitting in their house watching you drive down the road, they're sitting still, and your car is moving. So in that same scenario,
you're moving it away from one to one.
If I was standing at the tree, if I'm a part of the tree and I'm standing at the tree, I'm gonna be watching you moving towards me, not me going towards you. And that's only to show that, to try to say that because of this inference, we can say that the Earth is moving and the celestial bodies are sitting still, though they have their own individual orbits, which we can see that shows that we're moving as well. That doesn't work because of exactly what I just showed you, where the person is sitting in their house watching you move by. Like it's fine. It is not anything out of the ordinary or anything that goes against what we observe to say that we're stationary and we watch the celestial bodies move by. It doesn't.
You just need to come up with a mechanism that will cause the entire universe to move.
You're robotic.
You're in the mountains.
Is he just robotic for me?
No, he's in the mountains or something.
Okay.
I think the mountains are moving in front of his view.
Damn it, Jerry.
Like we 100% know that the car was moving if it hits the tree. You know what I'm saying? The tree's playing on the ground. You just drove all over the country. We can view this from every angle. We have tons of information, measure stuff. We just 100% know that the car moved into the tree and not vice versa, because we know how the shit works.
Well, if we were to apply relativity to crypto, would it be like the individual crypto going up in price, or just the rest of the market going down?
No, Jeremy, if I'm coming through now, my question would be, why would you think that the entire universe is moving and not us?
Dude, we can't even take it to the universe yet. We're not sure on the tree and the car scenario on which one's moving some of us. Are you sure at left lane? You're sure it's not the tree moving and it's you moving?
No, it makes
The
sense. No, what you're saying
PhD
makes
guy
sense.
doesn't know.
Obviously, the car's moving. You know, obviously the car is moving, right? Apply
And
that to a
what
stationary
kind of tree,
Earth in the
though?
universe. No, please stay on track. Apply that to the Earth in the universe. Why would you think the entire universe is moving?
What kind of tree, though, dude? Like, because
Shooting
if it's one of
stars.
those running trees, then it could be the tree.
Those sycamores are dangerous.
Yeah, they do have those running trees. I don't know.
You got to give them credit, though, right? Like to convince a whole population that they're actually moving at 1.5 million miles an hour at all these crazy velocities. I feel like
Yeah,
I'm
but
back to 2016 or something.
I mean, shouldn't we be seeing like a whole bunch of new stars every day if that's the case? Like, how is it that we don't see all sorts of new stars if we're moving through the universe at that speed? I don't know. Is there any Glover that can answer that?
Well, I can answer it. It's because the stars are moving with you.
yeah,
Okay.
we're in a,
Yeah, but that still doesn't answer what we would be moving into. We're moving into more space at, what is it, SE, over a million miles an
A
hour?
million and some change.
Yeah. So if
Faster
we're
than the speed
flying,
of light. Faster than the
right?
speed of light.
Okay.
Oh, if you're referencing stuff on the edge, then yeah, it's faster than the speed of light. Yeah.
So that's what I'm saying. Like, even if our solar system is moving through space, the entire universe at that speed, we'd still be encountering things, dude. It'd still be perceptional from the Earth's reference frame.
You know, in that scenario, they actually say nothing's moving. Like the galaxy here and the galaxy way out on the fringe, they say neither
Right?
one's
Because it's
moving.
all
It's just
moving together.
no. They just say the space is getting created in between them. But in order, I don't know.
More space is being created between them. I
Yeah,
mean,
it's dark
bro.
energy. You know, there's dark energy.
Bro. The
It's like some
creation of
real.
space.
It's like some real nerd Star Wars shit. Like every megaparsec or some kind of parsec thing. There's a little tiny amount of space created, and over 2 megaparsecs and 3 and 4, and you get enough space in between you. There's a lot of little bits of space getting created, and boom, you got stuff moving
So,
at faster than the speed of light. That's why there's
so
a
you're
limit
saying
to light. Go ahead.
you're saying space is being created. So
Yeah.
So where does this space come from, and where does it go to? So if you're saying space is creating more space, and the new space moves into the old space, I mean, it's really illogical. I know it's not your belief, Jeremy. I'm not placing this on you.
This
I'm
is
trying to
friggin'
make.
awesome. I actually like this. This is one of my favorite parts of their thing. We have friggin' unlimited space. If you run out of space, just wait, and there's just going to be more space soon. This is awesome, dude. I love it.
You ever hear, like they
You know
say,
what it
it's a
sounds like?
malformed question, right? Malformed, but this is not a malformed question. This is a question that there's no answer to.
You know what it sounds like? It sounds like over unity.
No, it sounds like, what's the last number? What's the last number?
I'm hearing over unity.
Yo,
Dude.
if you had a, this isn't.
I'm
Dyslov's
hearing
right.
something. Yeah, go ahead, Jeremy.
This could potentially be an over unity machine. If we were to tie like a chain with some gears on it and shit to one galaxy, right? You get one planet on one galaxy and tie some chains and gears to it, and then you were to stretch it all the way across and then tie it here stationary. Don't just have it fixed on the ground. Well, then you might get the thing where that planets actually move together because of the friction or something. But yeah, if it gets farther apart and that chain turns the gear on the one side, bro, you could get a little energy out of that.
Well, just think about it. It's something coming from nothing without any input, and the only output is more space.
It's showing they can't escape the ether concept. Like they have to redefine it, recapitulate it, but still.
Over unity, dude.
Yeah, exactly.
It may be.
Unity.
I don't know.
You've got more
It's
output than input. There's nothing. Yep. There's no input. Where's the input?
The ether.
I don't know. Like if you had a chain stretched that long with gears, and as they got farther apart, it turned one of the gears. I mean, maybe you could get electricity out of that. I don't know. You'd have to figure something out. What would you set up to get the energy?
I wasn't really taking it that far. Like, like.
No, yeah, you got to go
I
all the
mean,
way,
if
bro.
it was practical, I would put more thought into that, Jeremy. But I don't think this is even a rational, practical idea. I'm just trying to showcase the illogicalness of their assertions,
Do you
dude.
know how
Trying to
fast
say
you could
that.
get a gear spinning though? Because seriously, the one on the edge is moving at the galaxy on the edge is moving at over the. We're getting farther away from these galaxies at over double the speed of light. So that's a lot of like that could be you can move a chain, a gear, or something pretty fast like that. You know what I'm saying?
Oh yeah, dude.
Obviously,
I mean, if
we know that's not happening, right? We're just saying what their fantasy model claims.
It
But
depends
that
on what
can't
reference
possibly,
frame.
yeah.
It depends on what reference frame you're in. SE. Come on.
Yeah, where the camera's at. Yeah, depends where the camera's at.
they got something coming from nothing, bro. Space isn't a thing; it's the absence of a thing. And they're trying to say more space is coming from the absence of nothing. I don't know, bro. It's insane, dude.
That's what happens when man tries to figure out where they came from. Think about it. All the explanations from all walks of life is something came from either nothing or like a supernatural, right? Because we can't figure this stuff out, and we're not. Most people just don't want to accept it. Like, we'll never figure that out. Like, where's the edge of space? What? What's the last number? What? Where do we come from? What?
How they try to. It's like we determine time with the celestial bodies. So how could you place a time on the celestial bodies themselves?
Not only that, in their model, did you know that when you reach the speed of light, like light itself, they say is timeless. So when you reach the speed of light in their crazy model, time stops. Did you know that? I know it's crazy. That like I'm not saying I believe it, but in their model, time stops. So light is timeless.
Well, it's
in
the
their
same.
model.
It's the same concept as the things meeting together. It's the same thing when it boils down to it. Because with two things exerting the same motion meet together, there shouldn't be an impact. There should be a neutralization of that energy because it's the same energy. Um, yeah. So it's like the same thing as like when hitting the speed of light, you end up freezing still or time stands still. It neutralizes everything around you. Neutralizes the motion. Neutralizes.
Kind of like their magic centrifugal force and gravity cancels, like high wave and the low wave cancels out and all this stuff. The canceling part.
Yep. It's quite crazy.
Well, maybe sometime in the future they might get off this crazy cosmology that these people from the 1700s have come up, and they might let go, maybe the next generations, but these guys, there's like, forget it. There's just no hope. There's no hope.
Well, they
They're
can't
putting on.
rationalize. That's why it goes to just a recapitulation of rhetoric. It's not actually like understanding, because like with understand, like someone understands something when they can explain the same thing in many different ways. But if you notice, when it comes to these topics, regardless if they're a PhD, a master's, a savant, whatever, it's simply just a recapitulation of information. There's like no heart in it. There's no actual understanding because it's only
Well, it has to
understandable
be.
in the perspective that it's given.
The understanding has to be rooted in logic and rationale first, dude.
Exactly.
Like you don't even
Wait,
you don't have nothing if you ain't got that, bro. You just got a fairy tale.
I want
That's the difference.
I
Yep.
want to define capitulate versus reiterate. I don't know. Maybe you're saying the wrong word.
What's
See, I
Ella
don't
saying? You're
blame.
getting hung up on semantics or what?
No, he should understand what the verb recapitulate means if he's going to question it. So on those things, I tend to just stay silent when people do those and let themselves make them.
Yeah, I mean, we got to try to understand each other where we're coming from, not just point out the little ridiculous inconsistencies. But I mean, I don't even know that you were inconsistent with what you said, but either way, I'm sure it made sense.
You know what, bro? I don't think, and don't take this the wrong way, guys. I don't think the people, the ballers that argue for their model, I don't think they're qualified. Honest to God, I don't think they're up to date. And like I said, I don't hold anything against anybody, right? But I don't think they're up to date with their own model.
What? Well, I got a question about that.
I have
Because
a response to that too.
yeah, Jeremy's hot mic, and let's move him. I was always under the impression that from grade school, right, they gave us the Earth's model, the model of the Earth, right, the most basic, fundamental model that we were all indoctrinated with this nickel iron core, metal core, solid core, right, and then all the different layers of the Earth. Now, has that changed? Because I'm hearing notions that it's changed and that's not. It's been updated. What's the updated model?
It's a dynamo. Look, before we go on to that, hold on. Let me just respond to what SE said, though. Or go ahead, fine. Does anyone know the answer to that?
Globers being qualified. Globers are unqualified. Yes, I
let's
totally
answer
believe
Dyslo's.
that.
Let's answer Dyslo's question real quick, and then.
So is it still a nickel iron core?
Wow.
Did I say that
Holy
right?
shit.
You're good. I don't know, bro. Does anyone know the answer to that? Because I want to respond to SE still.
Left lane, come on, bro. It's your time to fucking pipe up, dude.
Apparently, it's solid now. It's not a molten ball. It's the stuff around it which is molten, which is spinning the other way.
Well, no, they've always said it's a solid nickel iron core, dude. And then around that is the fucking molten magma. And then you got the mantle, the crust, the fucking blah blah blah. But my point is that model's changed. I don't know that no one wants to pipe up now. Left lane, you there, dude? Put that fucking big ring in park, dude.
You want somebody
Before
to say
you go on
something
to that, hold on,
coherent?
man. Hold on. Before new people start jumping in, I still want to respond to what SE said. So before anyone new pipes up, let Dyslo get an answer to this, so I can do that, please.
What's the most modern version we got here, guys? Do I gotta fucking Google it myself, answer my own question, or what?
I googled it for you. It says redefining the inner core. Located 3,000 miles below Earth's surface, the inner core is anchored by gravity within the molten liquid outer core. Until now, the inner core was widely thought of as a solid sphere. The original aim of the scientists was to further apart the slowing of the inner core. It's less solid than previously thought, is all it's saying.
All right, cool.
So it's like a bouncy ball? All right, go ahead, Jeremy. Go ahead, Schlitzy. What do you got, Schlitzy?
You trying to get into some beef with the Globers over this?
Yeah, I'm trying to start a riot up in this bitch, dude. Saturday.
No, we just did that stupid friggin' thing with the dropping things.
All right, go ahead, Schlitzy. What do you got, bro?
Oh man, I still want to respond to SE, dude. You guys don't follow along with the convo at all.
Asking SE to elaborate.
Why are we letting Schlitzy go, dude? I've been waiting to get in.
Yeah, I wanted to comment on the same thing Jeremy did too, because it was a great point about Globers being unqualified to argue their position.
Yeah, let me just get it out real quick.
All right.
I think they are the most qualified. If you grab some PhD guy here, they don't know what's going on, dude. They might know a little bit about a particular aspect or something, but in the overall thing, if you had to put Kosho's Glover skills up against, any one of these guys, like Kosho, Zanuck, all these Glover, they are the most qualified. You're not going to find anyone else qualified on Earth to debate this, to talk about this.
You're saying that Kosho and you're saying Kosho and Zanuck are the best Glovers we got on Earth?
On Earth. Kosho,
I don't know. That Jamaican
Zanuck.
guy seems a little bit more sane than Zanuck.
I'm just saying, bro. A lot of there's some of these guys here, not all the Glover guys, but some of these Glover guys, like you're not going to find a more qualified Glover anywhere on Earth.
Oh, you mean more qualified as in not necessarily actually qualified?
No actual like PhDs or master's degrees or anything. I mean, Zanuck's probably got a couple, but like Kosho's just some kid, dude.
I get what you're saying, bro.
Yeah.
What you're saying is that the science, all the science departments, right? You've got PhDs in all these separate departments, and all these separate departments, they don't have any cohesiveness between them. where they kind of segue into each branch smoothly and kind of explain each other and like complement each other's explanations. It's all like subdivided, and the left hand doesn't know what the right hand's doing in terms of branches of science, whereas the Globers that come in here are a lot more well-rounded in terms of understanding the arguments from each angle and each different perspective. It sounds like that's what you're alluding to.
Yeah,
And I would agree. I would agree with that.
Yeah, these are the most qualified guys that exist on Earth. The Globers that come, Koshos, the Xanax.
Yeah, that's because science has no.
That's not what I meant, bro. That's not how I meant it.
Well, I know you didn't mean it that way. I see you couldn't formulate that intriguing of a thought, but the point is,
because you're Canadian.
yeah. Besides that I'm slow and all. Yeah. No, I meant it in a way that they don't know the current model. They're good at what Jeremy's trying to say. They're good at trying to come up with counterpoints to make up stuff on the fly, But I'm not talking about that. I'm talking about their current model. For example, when I talk about their current James Webb Plane Telescope, right, and the current findings, stuff like that. That's what I'm talking about. They have no idea. Most of them, they're going on older scientific stuff in their paradigm, in their cosmology.
Well, that was the thing with the Foucault pendulum yesterday was getting me quite upset, like that, because we've been told by the Globers for years that the thing moves back and forth in a straight line, and what's really moving is the Earth spinning under it. You know what I'm saying? So that was a bit frustrating.
Exactly. And what were they saying? Oh no, it's the pendulum deviating. And
some of the Globers know, like Rumpus, Xanax, they know their stuff. You know what I'm saying? There's some guys, that they don't quite know each and every little tiny aspect of a Foucault pendulum or this or that. You know what I mean? So,
I got a question about that. So if we took a Foucault pendulum in a near zero G environment, they're saying that it won't precess. Is that what they're claiming?
You can't get a plumb line in a zero G on a Kavana.
No, like like on the ISS or something along those lines where the gravitational effects are at its lowest. Like,
is it gonna? Pendulum? You couldn't get a pendulum going there.
You couldn't get a pendulum to precess in that sort of environment.
You can't get a pendulum to do what pendulums do because there's no without pulling the weight down.
Full force effects of gravity. That's what you're saying.
Yeah, there's nothing to pull the weight down. The thing on the end of the string, that's got to be like hanging.
Well, you got to understand what weight is to begin with.
Don't play that game with me.
Before we go into La La Land, the pendulum discrepancy is what they don't get or what they double speak on, or I think they just either don't understand or whatever. I don't want to start like that. Let me just rephrase it. The misunderstanding is that the pendulum in this so-called experiment is supposed to swing back and forth in a straight line. Now, some of them are under the impression that that's not what happens. It's that the pendulum itself precesses in the experiment, so-called experiment. Not the Earth moving, it's also the pendulum precessing.
Yeah, the thing Snooze said yesterday would totally debunk the idea that it's the Coriolis effect. At left or right acceleration, you would never measure that. You throw a baseball off a merry-go-round, the Coriolis effects that play, you're not going to measure any left or right acceleration. That's it. Like I said, some of them know specific parts, some of them don't. Left lane can tell you if the tree's moving or the car's moving. Other people can't tell you which one's moving. You know what I'm saying? Some people know about the Foucault pendulum, some don't. It's like a mixed bag. And there's some people that know that, they know more of it than others. That's all.
No, it's not like, it's not even that they know, but they dispute it, right? That's the thing. And when you tell them, no, listen, man, in your paradigm, it's like this. No, but it could be this. No, it can't be this or that. You have a specific model that claims a specific thing. So you can't just make it up, improv. I call that improv science. They make stuff up. And you're like in a position to explain their model. Like, wait a minute, no, it's not like that. It's like this in your model. Like, look it up.
Yeah. So
that's kind of what I was pointing to earlier. Actually, I had to have Ruhif come and correct some other Globers before, because the Globers tried to tell me that perspective does apply to the sky, which, of course, the logical mind would tell you, because the logical position is our position. It's funny to see them figure out that, oh, wow, my position is illogical.
Yeah, well, when it comes to applying perspective, if you're here for the Star Trail week, it's like Shark Week, but with Star Trails, we did it for about a week. If you were here for that, you'd realize that some of them think you do have to apply perspective to the stars, because you got an issue, and we heard a whole bunch of different excuses for this one. I think three different reasons for why it happens. Some of them were saying it doesn't, wouldn't actually see that. Other ones are saying you see it because of perspective, and there was another one, something. But yeah, you do have to apply perspective to the star. I think Kosho was the one saying, there was a bunch of them saying that that divergence and convergence at the celestial equator happens because of perspective.
Yeah, that's a total useless like conversation. When I hear perspective, I just tune out. Like anything like that, it's like a completely waste of words. Completely.
The thing with the horizon rising with you as you get higher in altitude, that you also have to apply perspective to the horizon because it's happening. You know what I mean? That's why it rises with you, because it's perspective.
Refraction.
And when it came
It's
to
an optical.
refraction, God,
Huh? I was gonna say no. The horizon is like an optical thing. It's not a physical place. But yeah, that's what you were
the
saying.
ground is definitely a physical place. Though you can get to the last bit of ground you can see, that's physical.
Well, certainly. But your horizon
geometric is probably the thing you're looking for. It's not geometric.
Yeah, no, it's not a physical geometric going over the curve. No, it's angular resolution limit of your vision. You can think of it either way, really. I guess that's the frickin', that's what confuses people is they think it's physical location over a curve when it's actually just the angular resolution of the limit of your vision.
It's not though, because we can resolve but it's not this. Hold on, man, because you said it twice now. It can't be the angular resolution, because we could zoom something in smaller that's farther away.
Yeah, but when you zoom in on something that's beyond the focal length of your camera lens, that thing will just pop out of sight.
Right. So so our eyes and tools that are optics have a limit, but then these globers look up in the sky and say, I can see forever.
The fact that you see those stars with your eyes and the camera lenses means they can't be that far away.
Yeah,
you have no
angular
idea
resolution.
how far away they are.
If it was angular resolution that was making things disappear, then we wouldn't be able to resolve things that are smaller, that are farther away. You know what I'm saying? There's a building in the distance. You can zoom in on a window. Why can't I zoom in on the bottom of that ship? If it was angular resolution, you'd be able to zoom in on the bottom of the ship.
Oh, you're talking about bottom-up obstruction when you're near. So we're near the surface. So your angle to that surface is part of that thing. I can point you to Shane's presentation that will
did you hear what I said, though?
Differentiate. Yeah, you're talking about a bottom-up obstruction that's caused by how close you are to the bottom layer here down near the surface where it's the thickest.
You said it was due to angular resolution, though. That's not it.
No, that's just obstruction of your vision. Because you're at wave sight, so those waves are going to block your sight any way you turn it.
Okay, now we're talking about different things: atmosphere, waves. I know, it can't be angular resolution, though, like I said, because we can zoom in things that are smaller, way smaller than the thing that we can't see anymore.
But when you're not listening. When you go beyond the focal length, you can't zoom in on things. They just disappear. That's just the limit of your vision and the limit of lenses.
I am listening. Like, you're not listening to me. You projected that onto me. I hear you guys. I heard what he said. He said you can't. It's because of angular resolution, but that can't be it, because if it was, we wouldn't be able to zoom in things that are smaller, way smaller than the thing that's disappeared in front of it.
I understand this. This is exactly the point that I tried to make like 3 minutes ago. That there's an angular resolution limit to your eye, and that's what the horizon actually is. And then when you're down here on the surface making observations, there are atmospheric conditions that cause a bottom-up obstruction. And those are two different things. There's an angular resolution limit to your eye, and then there's bottom-up obstruction caused by atmospheric things, and also your relation, because we're standing on a flat surface. You can do the same thing with a building, looking straight up a building. If you get your face right next to the building and you're looking straight up at it, the things that are really close to the building become obstructed. It's the same.
That would actually be a good test to do. That would actually be a good test to do, is to get a plumb line, drop it down, make sure you got a flat level surface. Like, buildings are generally not like flat like that. Like, yeah, they're plumb, but you've got indents for window cutouts and there's goofy shit on the side of the building. So if you did have a flat surface that just hold on a second. If you did have a flat surface that tall, you could you could test to see if you could zoom it in. You could look up, get on the bottom or get on the top, look down or look up, and see if you can't zoom it in anymore. That'd go a long way for our argument.
Yeah, it's part of Shane's presentation. It's in there.
If you're
did he actually do it, though, or is it just an?
If you're standing on the 10th floor and you look straight down, that floor is going to look closer to you. But when you move your eyes and you move them away over the floor to the horizon, you see that land changing. But it's perspective that's doing that. That's your eyes.
I don't think so, because as the things change in the distance, things go up, things go down. Sometimes you can Sometimes you can see the bottom of the ship. Sometimes you can't on different days. Think of the Black Swan with the oil rig. Your vision, the way you see isn't changing. Like the way you see isn't changing from day to day, month to month. If you're staying at Skunk Bay, I mean, your vision's your vision.
Yeah, but when you're standing on the 10th floor, that church tower that is in the same line of sight, that tower is the top of the tower is at the same height. So that way you can compare the distance from the building you're standing up and the distance in the building and the distance in the star. When they are at the same level, that means that the ground is also the same level. And I live in the Netherlands. It's pretty flat here.
Yeah, I didn't want to completely derail anything. I just wanted to make the distinction between, understanding the angular resolution limit to your eye, and then, your position as it relates to the surface that you're looking across will cause a bottom-up obstruction. And then, of course, atmospheric conditions also play a factor in that bottom-up obstruction. But that those two things get confused. And that's why there's an argument, kind of.
Yeah, people always think it's just one thing, but it's multiple things altogether.
I guess we got here by SE talking about the unqualified globers. And that, and I agree with Jeremy that, yeah, the people that come in here or whatever are the most qualified, and that they've actually been part of the argumentation, and so they know our arguments, but that still doesn't mean that PhD John's explanations for the celestial theodolite are woefully inadequate at best or disingenuous at worst.
Yeah, but there's not for nothing a limit on the distance you can use that theodolite, because if you go over that distance, that thing ain't going to measure good.
No, those little theodolites have a short, like, a range that they can be used accurately, I guess.
Yeah, it's 50 meters or 100 meters or something, not more.
Yeah,
celestial theodolite is using your eyeballs and an object in the distance, and that's what makes the theodolite.
Oh, yeah, I didn't realize that she probably didn't make the segue. Like, I just started talking about real theodolites. Yeah, so celestial theodolite and a real theodolite are two very different things, and that concept needs to be well understood. Because I heard him arguing about it, and he's like, no, the crosshair is the mountain.
Yeah, that's the elevation, the angle you're measuring with that theodolite.
No, the angle is your view to the ground, taking consideration what you're looking at. So what you're looking at, based on its elevation and the elevation of you, the angle between a planar ground surface and that angle of observance is what creates that angle. None of this is being done with the theodolite that everybody conceives. That's why it's being called a celestial theodolite, because it's not the tool, the theodolite, that tool. It's just using the concepts of that tool in with our reality, and we're making that tool with ourselves and our observance.
Yeah, but even with a regular theodolite, you can measure elevations in the land.
So Crizzle, I want to ask, assuming there's a 100-mile flat piece of land, 100 miles long, flat. You're 6 feet above the ground with your theodolite, and there's a tower 100 miles away that's 500 feet tall, 1,000 feet tall, whatever. It's taller than you are. What would you use to explain the fact that the top of that tower you actually have to look down at with your theodolite? It should be above you. You should be looking up at the top, but you have to look down at it.
Yeah, maybe the landscape is lower there. The sea level is lower.
No, it's all flat level. It's all the same elevation, flat all the way across.
Within the regular, yeah, what's 100 miles in kilometers? I have no idea.
It's maybe 120, something like that.
And that's going to be way off, because that's too far to measure with a regular theodolite.
Why is
it's
that?
Always going to be off. Because you just can't measure with that thing those distances. It's always going to be off by a factor.
But sure you can. I mean, we're looking at stars with them and measuring their elevation angle. How far away are they?
Since when do you measure stars with theodolite?
Well, the main question is, why do you have to look down at an object that's way higher than you are off in the distance? I mean, that's the whole issue, really. I'm not digging or anything, but that's the problem.
Yeah, but
to get the angle.
that's the same as when you have a drawing lesson with a vanishing point. That point in the distance will always look farther away, and that will rise to your eyesight.
But apparently, it's dropping below our line of sight.
Yeah, because that building is farther away, so that height of that building will come lower in your sight.
But lower, yes, but below your line of sight? Why is that?
Depends on the distance.
Why should it depend on a distance? If it's a flat surface and the object is taller than you are, why do you have to look down at the top of it?
Vanishing point, I would say.
Okay, well, I'm not going to belabor it, but I mean, I'm just pointing out therein lies the crux of the issue between the globe and the flat.
Yeah, but if you had the drawing classes, you know how to draw those angles, and when you look in nature, you see those same angles.
Yeah, I've done art quite a bit, and I understand perspective by definition within drawing. Just things get smaller as they move away, but it doesn't describe why things. If you say that taller things drop below your line of sight, why don't shorter things move above, and why don't things from the left or right cross that line of sight? Things on the left move to the right. Things on the right move to the left. Everything goes to a point at your line of sight, not above or below, but to a point.
But that has to do with your focal point of your eyes. Because when you have your vision, you will always focus on one point in that image. And that's where your line of sight goes to. And that is your vanishing point also.
Yeah, these are easy experiments, and I think the one person doing the best kind of in life observations, he spends most of his time doing them, is the guy who goes on here by the name of Plain Reality, and he's showing all of that based on time of day, different days and whatnot, difference where you're standing. It appears as though something that's higher than you is at eye level, or like you're looking above it. That's just perspective and atmosphere. It's an image that's being reflected in your eyeballs. It's not where the thing actually is.
The best way to show it is when you're standing next to a waterway and you're standing close to it, and you look at that side. But when you look in a cross line to the other side, that border of that water is going to seem a lot higher than that you are standing. But that's perspective. That ground really ain't higher than where you're standing up. Otherwise, the water wouldn't stay in that river.